longitudinal wave is made up of two zones, a compression zone, which is a region of high-pressure air particles, and a refraction zone. This is a stretched region between two successive compressions. The frequency of longitudinal waves is how frequently a vibration occurs. A higher frequency means a higher pitch.
The wavelength of a longitudinal wave is the distance between two zones of compression or rarefaction. A shorter wavelength means a higher frequency and a higher pitch. The period of a longitudinal wave is the time it takes for a complete vibration, or cycle of the wave. Period and frequency are directly related, period being the inverse of frequency. Wave speed refers to how fast the wave can be transferred from particle to particle. Wave speed equals frequency times wavelength.
One example of a longitudinal wave is the beat of a drum. When a drum is hit, the air surrounding the drum compresses inward, following the skin of the drum. When the drum returns to its normal form, this compression travels outwards in all directions. A zone of stretched air, or a refraction, immediately follows.
Okay, I'm filming.
Okay, that's it. That's good. You can stop. What you just saw was a longitudinal wave. When part of the slinky is gathered up and released, a wave of energy, or compression, travels along the slinky. A stretch zone, or a zone of rarefaction, follows.
The Doppler effect occurs when the source of sound is moving towards you at a speed slower than the wave speed of its sound. As it gets closer, the frequency of its waves becomes higher, and the pitch grows slightly higher. As it moves away, the frequency becomes lower, and the pitch is lower.
One example of the Doppler effect is the rising pitch of an ambulance's siren as it moves closer to you. As it moves nearer, the sound gets both louder and higher in pitch. What you just saw was an example of the Doppler effect. As the tuning fork moved closer to the camera, the sound it produced got both louder and higher in pitch.